All right, good. How about this? How about 2x minus 3 cubed? So instead of squared, cubed, right? How do we do this, right? What's the most efficient way to do something like this? Well, of course, you can't just cube each one, right? That would be way wrong. We have to actually go through this process just like this, but instead of 2 of them, we need 3 of them. That's going to be kind of not fun to look at, but here's what I suggest you do. It's the way I do it. I mean, everyone can do this a little different. I suggest taking any 2 of them and putting them together first. And I always like to take the second 2 and multiply those 2 together. So in other words, I would come over here to like do some scratch work, and I would basically do this work right here, right? I do this on the side. And then once I get this answer, I would take that and put it right here to replace these 2. Make sense?
Yeah.
So since we've done that problem, I'm not going to redo this. This would just become 2x minus 3. And then this answer we had here, 4x squared minus 12x plus 9. Right? And now, at this stage, you have 2 terms times 3 terms. And so you're going to use the expansion, right? Expanding this, you should do 6 multiplications and get an answer, right? Okay. Why don't you go ahead and do that? And when you get an answer for this, multiply here, 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 combine like terms. When you get that answer, raise your hand, and that way I get an idea of about when everybody is done. Just when you're done, raise your hand, and then you can put it back down. Getting about half of you done. Yeah, I think a little bit over half now. All right. What I'm going to do is I'm going to just silently up here, I'm going to work it out. Okay? And then you can kind of look up and see if you're getting the same thing. They'll check my work. Is that right? We're getting the same thing? Okay, does anybody have any questions? I know some of you are still working this out. Anyone have any questions on this? Sure? You sure? Yes? rational expressions. So really, rational expressions is us making an attempt to, instead of multiply polynomials, to divide them. And that's a lot harder to do. So let's take a look at our first problem from rational expressions. And the beginning of this is just getting us used to some of the mechanics that we need to do the operations later. So this is just mechanics. This problem right here is the same as a problem like this. If I gave you 3 over 15, that's a fraction, right? But you could still do what with it? You could reduce it, couldn't you? This is also the same as 1/5, right? 3 goes into 3 once, 3 goes into 15 5 times. So we reduced the fraction, right? What you actually did without really knowing is you rewrote the top as 3 times 1, and you rewrote the bottom as, 3 times 5? That's really what you're doing here. And then you are reducing this out by getting rid of the 3's and leaving it with 1 over 5. That's really what we're doing, right? But when we learn it, we just say, what number goes into both of these? 3. And then you divide 3 into both, right? That's what we do. Here, on a problem like this, you can't look at those and do the same thing. So when I put something, when you're faced with something like this, I'm not going to do your homework problem, sorry. Which one? 16, the numerator's a little, all right, I'll do 16. No, let's do 12. Let's do 12. X to the second power plus 4x plus 4 over x squared minus 4. All right, so like I said, over here, the way we do this is we just say to ourselves, what number goes into both of these, right? 3, and then we just reduce. We want to do the same thing here, but you can't look at this and be like, what number or what factor goes into both of these and then just reduce. You actually have to do some work. Like here we broke down the 3 as 3 times 1, and we broke down the 15 times 3 times 5. This step from here to here is factoring. You are factoring that number. You're writing it as its prime factors. And so we factor here. That's exactly what we have to do here is factor. So I need to factor the top, and I need to factor the bottom. So I want just an honest show of hands here, because I need to know where we are as a class. How many of you feel like you could factor that numerator and that denominator? Okay,
I'm going to be honest.
not sure? Okay. So this is where we're going to get to a point, like I said at the beginning of class. Everyone's going to be at a different level, right? So let me start by just going directly to it. And this is for the students who know how to factor this. We're just going to go right to it. And for those that don't know, I'm going to show what we did after I do it. Okay, so the top. Who wants to tell me how the top factors?
We put after the x squared with x.
So how does it factor?
I just say the factors?
Yeah, say
X plus 2 and x plus 2.
x plus 2, x plus 2. That is correct. That's the factorization of that numerator. All right, the denominator, who wants to do that? Oh, hold on. Go ahead. X plus 2 times x minus 2. That is correct. So this is actually what we call difference of squares, right? This is called the difference of squares, and that's how this factors. That's something you have to recognize. And then this one, who said that? Who gave me that one? How did you do that?
So the way I learned it.
The way you learned it?
Well, first you got to see if that expression can be simplified, if they all have a greatest common factor.
Greatest common factor
But
first.
that's as simplified as it can get on the top.
Okay.
So I learned that that third term, that is the two factors, those two the constants or whatever, multiplied together, and then you would get that. And that middle term is whenever you add those factors together. So if you do 2 times 2, you would get 4 for that fourth term, and if you add them together, you would get 4 for that middle term.
Okay, yeah, so everyone has a different method. And I bet you when you learned that, you probably learned that maybe in high school. I'm not sure.
I learned that one in middle school.
In middle school, okay, so, but you probably spent a lot of time on it, right? It
Yeah,
wasn't
you
like,
use it like
hey,
throughout
everyone,
all-
this is it. And then next class we'll have a test on it. Like in middle school, you probably spent weeks on it.
Yeah,
I'm willing to bet weeks. And it takes a long time with factoring to get to the point where you can see it like that, where you just see it, right? So the technique that was learned here was that whenever you have a trinomial, boom, 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 and you have x squared, then x, then a number, that you need to try and see if you can break it down into two things being multiplied together. And what you want to look for is to see if you can come up with two numbers here that multiply to be this number and add up to be this number. And so the candidates for that are 2 and 2, positive 2 and positive 2. Those two numbers multiply to be this and add to be this. And so then you just slap x's here. And now if you FOIL this out or expand, boom, boom, do all that stuff, you would get this, right? The difference of squares, that's a little different. That's like a formula you have to know, all right? This is a formula. You have to recognize you have something squared minus something squared, and you have to know that that breaks down to be this. Okay, so I'm going to continue, all right? We will have a little more practice with the factoring, but let's just move through this problem. Here, at this step, this is kind of like we were here, where we had 3's on the top and bottom, and we could get rid of them. We're going to do the same thing here. I have an x plus 2. X plus 2, I'm going to get rid of those factors. And then all I'm left with here is x plus 2 over x plus 2. Or sorry, x minus 2, right? And then I can cancel the x's. Oh, no, don't do that, right? You cannot cancel these x's, right? Why can't you cancel those x's? You know how I did this earlier to help you? When you're learning this stuff, if you're confused, give yourself an example, right? Can you cancel these 3's? What's the top? 5. What's the bottom? 1. The answer here should be 5 over 1, which is 5, right? If you cancel these 3's, what do you now have? 2 over negative 2, which is negative 1. So which one is right?
With the
The first one, right? You're not allowed to do this, right? So this is our answer. We're done. All right, now let's do number 16. X minus x squared over x squared plus x minus 2. All right, so for those of you who are feel pretty good about your factoring, my question to you is, what is the very first step of factoring, like all the time? What is the very first thing we always do when we're trying to factor something? Greatest common factor. We always try and see if there's something you can pull out of both, right? That's always step number 1. So here, on this one, is there something that is common to both of these terms? They both have an x, right? So I can factor an x out of the top. So I can rewrite this as x on top. And then what would go in those parentheses? 1 minus x. And to double check, if you multiply this x through here and here, you would get back this. So that was a GCF factor, greatest common factor. Now on the bottom, do I have a GCF on the bottom? Is there something that goes into all 3 of these?
Negative 1.
You can do a negative 1 if you want it, right? But other than like 1 or negative 1, are there any other numbers that go into both all
No.
of these? No. Are there x's in all of them?
No.
No. So there's no GCF here. This looks like the problem we did a second ago, right? Where we had to come up with those 2 numbers. Let's see if we can try it. You need 2 numbers that will multiply to be this, but add up to be this. 2 numbers that multiply to be negative 2, but add up to be this. Positive 2 and negative 1, right? Positive 2 and negative 1. So I'm going to put here plus 2 and minus 1. And then in this space in front, I put x and x. So like I said at the beginning of class, the expectation here in 1414 math, STEM, right, is that you are pretty good with your factoring. So if you're not, I don't want you to like give up on this, but you need to get caught up. And that's going to take some work from you outside of this class. All right, you're going to have to go get help. You cannot just continue showing up, not knowing how to factor, right? You're just going to be wasting your time because eventually is going to get you, right? The test, quizzes, or whatever. All right, you all good with this? The ultimate goal is to try and cancel something out here, just like we did over here. We got rid of these x plus 2's. The problem is, as you look at it right now, it does not look like anything cancels out. Like nothing looks identical, does it? And this is where you have to see something that's going to show up a lot in Calculus 1, and that is that when you have two expressions that are almost the same, but they differ by a sign. So notice on this top parenthesis right here, this is really a positive x, right? And a negative, a positive 1 and a negative x, right? And here, this is a positive x and a negative 1. So they're opposite of each other, right? They're opposite in terms of signs. So what we do in this case is we factor out a negative 1 from either this one or this one. It's your choice. I'm going to pull a negative 1 out of this. And if I do that, this will now be minus 1 plus x on top. And on the bottom is x plus 2 and x minus 1. Show of hands, how many of you knew I was going to do that? So a few. For those who didn't see I was going to do that, do you all understand what I'm doing? Do you understand what I'm doing? Why I'm doing this? Anybody? Yes? You're okay with it? Yes? You're okay? So, if you multiply this back through, this and this, that's 1, this and this, that's negative x. So that's the same exact problem, right? The same exact expression. However, these two, are they the same now?
Yeah.
Yes, they are. I'll go one more line. This is x times negative 1. In that parentheses, I'm going to rearrange the order. I'm going to write it as x minus 1. That's just to help you see that those are the same now. Right? And now, these two are identical. Does anyone have a question as to what I just did? And that's usually a step that students are like, okay, I can do that? Is that allowed? Yes, it's allowed. You can always factor negative 1 out of anything. You only do it when you need it, though. Here, I needed this. I had to see these two were off by a sign. So I pull a negative 1 out of the top. That changes the signs in here. And then I just rearrange it so I can see that these two are exactly the same. And now I'm going to cancel them out. And I'll be left with, what is that on top? Is that x minus 1 on top?
Negative x.
It's negative x, because you're multiplying those two. So it's negative x over, and then x plus 2. Okay. Question?
I forgot, can you do that to the numerator and denominator?
You can do it to the denominator as well if you want to, but that wouldn't, if you did it on the bottom at the same time, if you pull the negative out of this one, then now they're still going to be different. Because it's going to change this, and now they won't match anymore. Could you do it? Yes. Your answer was could you. You can, but you wouldn't want to. Could I have pulled the negative out of the bottom instead of the top?
Yes.
Yes, I could have just done it on the bottom and left the top one alone. It's totally up to you. Okay, that is our final answer over here. All right, while we're talking about this sort of cancellation, I've done this cancellation 2 times, right? So far I've done this twice. So I have a more abstract question for you. I know y'all have seen functions. I know you've seen functions probably in the past. I'm not sure at what level, but if I give you something like this, f of x, I write this equals 2x plus 1. Are you all comfortable with the idea of me saying, hey, what would happen if you plug 3 into this function? That you just replace the x with 3? Okay, everyone's good with that? Okay, so here I have a question for you. I'm going to define 2 different functions for you. That one and this one. This first one is going to be the function 1, which means that no matter what you plug into it, it doesn't care, it just always spits out 1. Okay? And then this one is the function x over x. All right, I have 2 different functions. All right, what happens if I tell you to plug 2 into this? What do you get?
1.
1, right? What if I say plug 2 into this?
You get 1.
You get 1, right? What if I say plug in 3 to this? What do you get? 3 to this?
1.
1. 5 into that?
1.
Divide into that.
1.
1. Are these the same functions?
They're different functions, but they define as like the same thing.
So do they do the exact same thing? In
Yeah.
other words, can you just like cancel these x's out and turn this into a 1? And just, are you allowed to do that? I mean, like we did here, we canceled these, we didn't, like, we did it, right? No one had any issues with this, right? Right? Okay, these two functions are not the same. They are not the same functions. Because what happens if I tell you to plug 0 to this? What do you get? 1,
Yeah.
right? And what about 0 here?
Undefined.
Undefined. 0 divided by 0 is undefined, right? 0 divided by 0 is undefined. So these are not the same functions because this function can handle 0 being plugged in. This one cannot handle 0 being plugged in, right? So they are different, only at 0. Every other point you can plug in, they're identical functions.
No, this is a restraint here, this is.
Yeah, if you graph this function right here, here's what it would look like, a horizontal line at 1. It would just look like a flat line like this. If you graph this one, here's what it would look like. It would be a horizontal line, flat like this, but at 0 there would be a hole. That's the difference between those two graphs. And since there's a difference in the graphs, there's a difference in the functions. Why am I telling you this? I'm telling you this because when you cancel these factors, okay, what we're saying is that the original problem, well, I don't remember what this one was. What was this original one? What did we do here again? Was that? Yeah, that was that one. What we said was x minus x squared over x squared plus x minus 2. We did the work on this and we turned it into this, didn't we? We said that that's equal to this. Right? Isn't that what we did?
Yeah.
But there's actually a little catch here. Right? There's, well, actually a pretty big catch. And that is, you know when you're like signing something, there's always like that small print with the little asterisk at the bottom, right, that you're supposed to read?
Yeah.
Okay, there's a little asterisk down here. When you cancel this right here, you create this asterisk. And what this asterisk says is that this is equal to this so long as what? X is not
Equal.
what would have caused a problem there, that we somehow eliminated this problem when we canceled it out. What if X was not 0, 1? What if X was 1 here? What would happen?
There's a hole.
So if you try to plug 1 in right here, you're going to get 0 over 0. Try it. 1 minus 1 squared is 1. 1 minus 1 is 0. 1 plus 1 minus 2 is 0 as well. You see you get 0 to 0 here if you try to plug 1 in? What happens if you plug 1 in here? You don't get 0. You see that? So these two are equal so long as you don't, so long as x is not equal to 1. Then you can say these two are equivalent. Now that's extremely important in calculus. Because in calculus we do this thing called the limit. And when you do a limit, you're like letting things get close to things without actually being those things. And so we need to understand that little asterisk is there. Every time we cancel a factor, there's this asterisk, right? I don't believe I'm going to test you on it. The book doesn't talk about it. But yeah, this is the value of having somebody who knows where you're headed, is that I can explain this to you now, kind of get you to see a little bit here. That way when you get to it in calculus, you're like, okay, I've seen that. I know what you're talking about a little bit. All right? Okay. How are y'all feeling? You ready to do one on your own?
Yeah.
Yes, you are. Of course you are. All right, so let's do... Does this seem like a long class?
It does.
It does seem long? Yeah. All right, so here we go. So I believe this is going to probably put some strain on some of you. But if there's any time to figure out where you are, it's going to be now. All right, that problem right there, what I'd like to do is I'm going to step out of the room for about 10 minutes. Maybe not that long, maybe about 6 minutes. And I'm going to allow you to talk to each other. I don't want one person just like, hey everyone, here's the answer. I want you to talk to your neighbor, see where you are with this, all right? I will give you the hint that you need to factor the top and bottom. You need to break them down. 2 sets of parentheses, 2 sets of parentheses. Let's see if you can do it though, all right? Got it? Try it. Now if you're stuck, if you're, might turn to your neighbor and be like, hey, are you stuck too? And maybe as groups you can successfully get through this. We'll see. All right. I'll be back. I like to leave the room because that usually promotes a little more interaction between you all.
Oh yeah. So then it would be, so they would have to multiply negative 6 here. I haven't canceled it. So.
Well, like, you could, all this was like parentheses.
So whatever.
Like to the first.
So did you divide that?
Whatever it's called. Yeah, like the first y.
So whatever you multiply,
Yeah.
like that negative 6, whatever you get, so this one's simplified.
So for the numerator, what I did is, the leading coefficient is 3, the last number is -2. So you multiply, I like to do a little x and everything on top. So you put 3,
Yeah,
3
this
times
is multiplied
-2, which is -6 on top. And then at the bottom part of the x, it's the middle coefficient, which is b. So it would be just -1. So then you gotta find 2 numbers that equal to -6 when multiplied, but -1 when added. So I got -32. So it's y minus 3, y plus 2. And then at the bottom you do the same thing. Because you're adding, so you need to get a number that equals to, you need to get 2 numbers that when multiplied that equal to 6. And they're equal to 5. So it would just be +3 and 2.
Okay, so when you're multiplying, you're just multiplying this end over here, right?
So that's right. I think I'm missing something with the y squared. You're 22.
I'm 23.
It's not that. It's not that.
And it's never too late, right?
a method? Do you
Oh,
have an idea?
Okay. Well, it's kind of, I think I'm doing it right now.
What really makes it complicated is the three.
Yeah, I forgot that.
You're at the point right
I
now.
think I was supposed to be in California, like my transcript, my AP, my credit just transferred. So like,
That when I multiply
I'm
these,
gonna go through and show you. But it's important to get to the
So
we do like that.
currently you have to multiply the first coefficient to this, so you get 6, or negative 6.
Right in the front throws them off. Okay, so we'll address it. How about you? You're okay? Yeah.
Yeah.
Really?
Yeah, so those three, that should come here, that looks like you make it 6.
Because the way that's
how times it is, like,
So you have to find
You're okay?
I guess so.
How do you feel about it?
I did biology.
if it's right, then we can
Did you go have or so you're okay, all right, we are, right? So we're all kind of the same place? Okay. Were you able to get it? Yes, check. Okay. I know what's happening, the three in front is messing everyone up.
I think I factored it, but I know it was.
I was doing like a
Okay, all right, we'll go over it, I'm just trying to see where everyone is. How are we here?
Well, looks scary, but then once you get it, it's not that bad. You get to realize like all these
So are you okay with it? Like, you understand what you're doing?
well, there's a subject right here that doesn't really.
I'm gonna go through it.
But it's not.
I'm gonna go through it. So
what I
let's
did.
see where we are. How about you?
I did the first two exams. Like,
Go on. How about you?
So like, you don't get to break down. So they don't do it there.
So you feel like, are you like guess checking, trying to like fill in the numbers,
And
like
then second
make it work?
semester, you start doing it. It's like super like cheeky.
Okay, good. I mean, so you have something, right? There's something you're trying. All right, I just want to make sure you're not just looking at it going, I have no idea. You know? Okay, we're gonna go over it. I'm assuming you're okay?
Yep.
Yes? Did you guess and check just to make the numbers work?
Yeah.
Okay, how about here? Yes? How about back here? Don't know, so unsure? Do you have a method that you're using? Like, do you have something are you just trying to make numbers work?
So initially, what I couldn't really figure out how to get to 5, so I
Okay, all right, we're gonna go over it. How about you? Do you have a method